We're surrounded by them, those little white boxes you see on the wall in homes and businesses. But we hardly ever think about what's going on inside. Well, today, we're going to pull back the curtain on the silent battle of wits happening inside our security systems. And trust me, you'll be surprised at just how clever they really are. So, have you ever walked past a motion detector and just wondered, what is that thing really seeing? Is it tracking your movement? Is it sensing your body heat? Maybe some kind of invisible wave bouncing around the room? That's exactly the question we're going to break down. But before we get into all the cool tech, we first have to understand the #1 challenge that every single security designer has to deal with. It's this constant, delicate balancing act between two goals that are always fighting each other. And this right here, this is the core dilemma. On one side, you have the probability of detection. Obviously, you want this cranked up as high as possible, right? You want to catch every single real intruder. But if you make it too sensitive, the other side of the scale just tips right over. That's a high nuisance alarm rate. We're talking about the alarm going off because your cat decided to explore the countertop, or a big gust of wind blew a branch against the window. And those can lead to some seriously hefty fines from the police department. So the entire game is finding that perfect balance. Honestly, every piece of technology we're about to look at is just part of this elaborate engineering hunt for that elusive sweet spot. It's all designed to build a system that's incredibly sensitive, but not, too sensitive. So let's start at the most basic level possible. How does a sensor even talk to the main alarm panel? It all comes down to the really simple language of electrical circuits. The simplest circuit out there is called normally open. The easiest way to think about it is like a doorbell. The circuit is open, so no electricity is flowing. When you open the door, it's just like pushing that doorbell button. It closes the circuit, electricity flows, and the alarm goes off. Simple, right? Yeah. But it has one massive problem. And here it is, the fatal flaw. It's a big one. If an intruder just snips the wire, the circuit just stays open forever. The alarm panel has absolutely no idea that it's been tampered with. That sensor is now completely disabled and the whole system is blind. So, to fix that, the industry standard became what's called a normally closed circuit. In this setup, a tiny little bit of electricity is always flowing through a closed loop. So now, if a door opens, or if the wire gets cut, the loop breaks, the current stops flowing, and boom, the alarm triggers. It's basically fail-safe. This seems pretty foolproof, doesn't it? I mean, what else could you do? But what if a really clever intruder found a way to bypass that sensor without cutting the wire? What if they could trick the panel into thinking that loop was still closed, even when it wasn't? The solution to that is an amazing concept called supervision. Engineers add a tiny little component called a resistor to the circuit, right there at the very end of the line by the sensor. Now, the alarm panel isn't just looking for a simple on or off signal anymore. Nope, it's looking for a very, very specific electrical signature. This table breaks it all down. So under normal conditions, when the door's closed, the panel is reading a specific resistance. Let's just say it's 2,000 ohms. It sees that and thinks everything's secure. Now, if the wire is cut, the resistance shoots up to infinity. The panel sees that change and triggers an alarm. But here is the truly genius part. If an intruder tries to short the wires together to bypass the sensor, the resistance drops all the way to 0. The panel sees that too, knows it's not 2,000, and flags it as tampering. It's such a simple but brilliant solution. Okay, so we've got smart wiring, but what about the sensors themselves? How do they actually detect someone moving around in a room? Well, there are two main technologies at play, and they work in completely different ways. So on the one hand, you've got passive infrared, or PIR. It's called passive because it doesn't send anything out. It just sits there and watches the room for any rapid changes in heat, kind of like a form of night vision. On the other hand, microwave sensors are active. They actually fill the room with microwave energy and then look for any disturbances in that field, sort of like how a bat uses sonar. But these PIR sensors, they have some serious blind spots. For one, they can't see through glass. And on a really hot day, if the room temperature gets close to our body temperature, a person can become almost invisible to the sensor. And, you could just cover the lens with some paint or tape and blind it completely. Now, microwave sensors have the exact opposite problem. They can actually see too much. Those waves can go right through drywall, which means a truck driving by outside the building could potentially set off an alarm inside the room. Total false alarm. So, We've got one sensor that's pretty easily blinded and another one that sees way too much. What's the solution? Well, you combine them. And this is where security system design gets really, really elegant. The principle is something called AND gate logic. It sounds technical, but it's incredibly simple and super powerful. The sensor will only send an alarm signal if the PIR sensor and the microwave sensor trip at the exact same time. If it's just one or the other, it's not good enough. Let's just walk through a couple scenarios. Okay, scenario 1. The air conditioner kicks on, sending a blast of cool air into the room. The PIR sensor sees that rapid temperature change, and it trips. But the microwave sensor sees absolutely no movement. So what's the result? No alarm. The system ignores it. All right, scenario 2. A big truck rumbles past the building. The microwave sensor's waves go right through the wall and detect that movement, so it trips. But the PIR sensor, it sees no change in heat inside the room. So the result, you guessed it, no alarm. But now, let's look at the final scenario. An intruder, a warm, moving body, walks into that room. The PIR sees the change in heat, and the microwave sensor detects the physical movement. Both conditions are met at the same time. The result? Now we have a confirmed alarm. It's go time. And here is a fantastic real-world tip that just shows you how sensitive this all can be. Someone once told me never put a dual-tech sensor in a room with party balloons. Why? Because when the HVAC system kicks on, it'll make those balloons float and drift around. The PIR sensor won't see them because they're not warm, but you can bet that the microwave sensor will see that movement every single time, causing a false alarm whenever the heat or AC turns on. So I think the big takeaway here is this. Truly effective security is never about finding one single magical piece of technology. It's all about creating layers of clever engineering, the supervised wires, the dual-tech sensors, all working together in concert to filter out all the noise and pinpoint the actual, real threat. So now that you actually know what these systems are looking for, it kind of makes you see things a little differently, doesn't it? Take a look around your own world, your home, your office. Where are the sensors? And, more importantly, now that you know, where are the blind spots? Thanks for watching.